So this is just a quick follow-up. I wanted to code out that essentially the algorithm from Itertools for combinations. So I'm going to go ahead and do that. And one of the things I'm going to do here is I'm going to use the idea of a yield, okay? And I'm not going to be exactly returning anything. I'm going to be yielding to an object that can then be used to call data out. So it's a slightly different concept, and I'll do my best to just indicate where that's actually happening. So this is, let's put it here, this is the combinations algorithm based on Itertools combinations. Okay, so def, I'll call this combinations from Itertools. And again, we're going to use a list. We're going to pass in a list of things, and we're going to get k combinations. Oh, I'm sorry. We're going to get combinations of k items. So this is, again, if there are n items in the list, n choose k, right? We're going to get every combination that satisfies that. So the first thing, let's get a tuple of, so this is sort of like a permanent version of that list, right? So I'm calling that a frozen version of the list. And then I'm going to get a value of n, which is the length of our input list. So pretty simple. I could have done length of list. It doesn't really matter. And the other thing that we want to consider is, well, I'm going to put in some kind of fault control, and I'm going to say if k is greater than n, well, that's nonsensical, right? We can't have 10 choose 20. That doesn't make any sense. So I'm just going to put a little bit of fault control in there. All right, so in here, I'm going to set up these indices, which are going to be a list in the range of k. Now think about what that means. List in the range of k. So that's going to be a list that is k long, and it's going to start at 0, and it's going to go up to k minus 1 in terms of the indices. So we can print that if we want. Why don't we do that? And I'll sort of call this as we go, since there aren't really strong time constraints here. So let's pass in, I don't know, this base 5 that we were looking at before. And maybe we can do, we'll make this 5 choose 3. So base 5, and we'll choose 3. Okay, so why don't I run that? So 0, 1, 2. Well, that makes sense, right? We've got 3 items, the 0th, the 1st, and the 2nd place. Okay. So let's go from there. I'm going to yield a tuple of that list frozen sub I for I in indices. So what is that doing? Okay, list frozen sub I for I in indices. So this is going to be list frozen sub 0, list frozen sub 1, list frozen sub 2, which are going to compose a tuple, which is then going to be yielded out. Okay, so that's one of the items. That's one of the things that's getting quote unquote returned. Return is not the exact word we want to use, but we're yielding it out to the generator that we can call to get all our combinations. And then I'm going to make the the infamous while true loop. I'm going to say for I in reversed range of k. So think about range of k, and think about what it means to have it be reversed. right? If it's 3, if it's range of 3, then it's 0, 1, 2, and that's going to be 2, 1, 0. Okay, so that's easy. If indices sub I are not equal to I plus n minus k. So what is n? N is, in this case, it's going to be 5, right? So that would be 5. And k is 3. So I plus, so I is going to start at 2, and it's going to be 2 plus n minus k, which is 5 minus 3. And indices sub I should be, let's see, that should be 2 at that point. Yeah. So I believe that will evaluate true on the first run, and it will break. And then otherwise we can return. And let's see. So we'll increment our indice by 1. And just think about that. We're saying like index sub 2, the value that's in there is going to be increased by 1, which is going to move us, right? It's going to move us across the 5 items that we are looking at here. So you can imagine we're starting off with salamander, fish, cat, and we're going to push across those. And then I'm going to say for j in range, and we'll go I plus 1 up to k. Indices sub j is going to get indices sub j minus 1 plus 1. And then we should be able to yield a tuple of the frozen from list frozen sub I for I in indices. Okay, so notice there's not going to be a return here. All we're doing is we're taking a combination, and then we're effectively like looking at the next item. And you can imagine salamander, fish, cat. Well, then salamander, fish, dog, salamander, fish, bird, and then we're going fish, cat, dog, fish, dog, bird, cat, dog, bird. So that's effectively what we're doing. Oh, I should probably print that result. So for com in combinations from Itertools, let's print every one of those combinations. Oh, list frozen is not defined. That makes sense because I called it LST frozen, not list frozen. Okay, that looks fine. And so we have, as I said, let's just look at what we're getting out of this. Salamander, fish, cat, salamander, fish, dog, salamander, fish, bird, salamander, cat, dog, salamander, cat, bird, salamander, dog, bird, fish, cat, dog, right? Fish, cat, bird, fish, cat, fish, dog, bird, cat, dog, bird. And so we're basically like, moving to the right and disposing of things that don't already, avoiding things that already exist through some simple shifting of our indices.